My name is Aaron Smith, and I'm joined as always by Nancy Bakeman with the Energy and Environmental Building Alliance. And this is our EBA webinar and podcast series. And again, as always, you can listen to this in replay on eba.org in the Academy or on the Better Homes, Better Future podcast. Got a chance to have some great conversations with KB Homes. They have participated in a Connected Communities grant with the Department of Energy. And at our summit in Salt Lake this past year, I said, we would love to hear more about this. We'd love to have your team report out to the EBA community and really share some of these learnings. So as we got ready for today's call, I think we talked more and more about having them back to the summit October 1st through 3rd in Salt Lake City and reporting out on even more of the lessons learned out of this project. But let me just start by introducing Ariel Chen and Jacob Atala from KB Homes. They'll be talking about the Energy Smart Connected Communities. And this is really the first microgrid community in California. As always, put your questions in the Q&A section or in the chat, and we'll ask those either throughout the presentation or we'll have time for some questions at the end. So with that, Ariel, I'd love to turn it over to you and Jacob.
Thank you, Aaron. Thank you, Nancy, as well. So hi, everyone. Welcome. Thank you for joining us. Today, we'll be sharing about what we're calling our Energy Smart Connected Communities, which is what we believe to be the first of its kind microgrid community in California. My name is Ariel Chen. I am the Sustainability Manager for KB Home. I am responsible for developing and managing our impact-related initiatives across the country. And I have the immense privilege of working with Jacob Atala. Jacob, do you want to introduce yourself?
Sure. Good afternoon, everyone. Jacob Atala, Vice President of Innovation and Sustainability at KB Home, past board member of EBA. Great organization. We're very happy to be here with EBA's continuing series on energy, smart energy, and hopefully today we'll present a little bit of this project and what we're learning from it.
Thanks, Jacob. All right, let's go ahead and get started. Okay, so what is this Energy Smart Connected Community? So this is what we are calling our two blackout-resistant communities. It's comprised of over 200 all-electric, solar-powered homes designed to use 40% less energy than a typical new home in California. And this is all backed by a community battery, which provides microgrid capabilities. This project is located in Menifee, California. Each of these homes is designed to achieve net zero energy. The home solar and in-home battery system can deploy energy to the home at night or automatically in the case of a grid outage, all with a seamless power transition, just so that there is very minimal impact to the homeowner experience. The home is also designed with efficiency in mind, of course, with performance appliances and smart home technologies that can monitor and control home energy usage down to the individual appliance level. So we are really hoping that these two communities here, these can serve as a blueprint for what we like to call resilient living in the future. So when I'm talking about resiliency here, I'm of course talking about climate resiliency. So we are definitely seeing a lot more severe weather events across the country, which can lead to things like grid instability. But I'm also talking about economic resiliency. So with these home, customers can expect a lower total cost of ownership since they can expect to have a lower annual energy cost than other typical new homes of the time. In terms of certification, all 200 plus homes will be meeting Energy Star certified standards, WaterSense labeled home standard, Indoor Air Plus, and of course the DOE Zero Energy Ready Home certification as well. So before we go any further, I just wanted to share a little bit about us. We at KB are quite proud of our almost 2-decade-long sustainability journey. KB Home was the first production builder to make a broad commitment to Energy Star, and we have designed our homes to meet these certification standards. So less than 10% of annual residential construction across the country meets these standards. So you'll see KB built towards the top of the pyramid. And we're very proud to have built more Energy Star certified homes than any other builder. Additionally, most recently in July 2022, we also made a commitment to begin building to WaterSense labeled home standards in Arizona, California, and Nevada. So at KB, we are quite proud to strive to do what's right, not just for our business, but also for the planet. All right, and before introducing the project, I definitely want to take a moment to identify our project partners. This was not just a KB project. We did not do this on our own, and this project would not have been possible without these fantastic folks. So first, the Department of Energy. As Aaron mentioned earlier, this was part of this project was part of the DOE Connected Communities program, so we are quite thankful for the DOE's guidance through this project. We have the fantastic team over at SunPower who conceptualized and designed these new communities along with our team. They also oversee the energy services technology, like the solar panels and batteries at each home. We also have the very sharp folks at the UCI Advanced Power and Energy Program who will be doing the data collection, the study, the testing for the microgrid events. We have Schneider Electric, who is responsible for engineering the microgrid and also providing home electrical technology. Southern California Edison, our utility partner, and Kia, who will be piloting and testing some very neat vehicle-to-home technology at these communities.
Ariel, can I add there, just for thought for everyone on the call? There are probably two kinds of microgrids. I want to say microgrids that work with the local utility and microgrids that want to exclude the local utility. In our program here, we think that in majority, going forward, in the majority of cases, a microgrid would need to work with the utility rather than exclusive of the utility. And therefore, the layer of Southern California Edison being part of the partners that understand that will help us create a microgrid template, if you will, that works with the utility rather than against it or without it, was an important thing, and something for anyone that's considering microgrids going forward on their projects, something to consider very carefully.
Thank you, Jacob. All right, next up, I just wanted to mention the Connected Communities program, just in case some folks on the call are not as familiar with this DOE program. The Connected Communities program, the program goal is really to support projects related to grid interactive and efficient buildings across the country. So our grant objective was around load shifting using energy smart technologies. So we were very fortunate to be awarded a generous grant to pursue this project. So this image right here shows the result of our efforts. This is one of our model homes in the Durango community where we installed an education center in the garage so that customers could learn about the special features associated with these homes and these communities as they walk through the model home and also as they just casually browsed. Beyond the Connected Communities program, we also look to make this the largest zero energy ready home communities in California to date. And we even went beyond some of the zero energy ready home requirements to try to really build out the benefits for our customers. So as a result of all of this collaborative efforts and our partner contributions, we were quite honored to receive some recognition this past year from the Department of Energy, where we received the Housing Innovation Award, the Environment and Energy Leader Award for a top project, of course, the EBA Award for Excellence in Resiliency, and of course, and then a recognition for Fortune as well through their Change the World Award. Alrighty, technologies and features. Let's dig into what makes this project what it is. Okay, so while the full community is a microgrid project, each home within the community can essentially operate as its own nanogrid. And this is because of the SunPower technology here. We have the SunPower solar system installed on the roof, coupled with the SunVault battery and the Hub Plus panel located in the garage of each and every home. This energy storage system, it regulates the best times to switch over to backup energy during an outage. And it also allows the occupant to be able to customize their home backup controls. There's also a dedicated My SunPower app, which allows for further customization and allows the customer to also be able to get an analysis of how their system is performing and also get any sort of alerts about their system. So with the advantage of this system here, coupled with the community battery to be installed, the home features has the potential to provide a self-supporting energy system that can potentially operate independently during a grid disruption in the future. Each home also has a Schneider Electric Energy Center smart panel. This is an all-in-one electrical smart panel. This panel here was added to enable integration of distributed energy resources and to also be able to control them all simultaneously. So this allows for the optimization of utility power, solar power, energy storage, things like EV, and also allows for the potential of future devices to be added by the homeowner later on as well. Some other neat features that are in every single home is the Rheem Proterra hybrid electric heat pump water heater. So that's this one to the top left. Smart water heater. It has some built-in technology that allows for temperature control, energy usage monitoring, and also leak detection. And this can all be done from a mobile device. What's really neat about this one, though, is that this Wi-Fi connectivity, it enables homeowners to be able to participate in VPP, virtual power plant programming, for load shifting and energy cost management purposes in the future as well. So that's quite neat. We have a Ecobee smart thermostat, and that it allows for controlling of thermostat from your phone, of course, but it also integrates quite well with our smart home system. We have a two-stage carrier heat pump. And so this unit can cool homes more efficiently, remove humidity a lot better than a single stage system. And it can also be connected to the Ecobee thermostat that you see next to it, so that homeowners can, again, participate in a VPP program. And finally, each home also has an ERV, an energy recovery ventilator. So this is just a continuous ventilation system that can continuously bring in fresh air into the home. And we chose this also because it operates at a sound level that's quieter than a comparable whole house cooling fan. All right, so since this is a smart home, we also have some smart tools and apps to go along with it. So up top, we have Wiser Energy. This is a home power monitor, which helps occupants manage the electricity usage in their home from the circuit all the way down to the individual plug level, all from the Schneider mobile app. So this includes things like real-time access to their home energy usage and the ability to control what's powered on at any time straight from their phone. And we also have SunPower's My SunPower app, which allows for remote monitoring of the home solar, battery, solar storage, and electricity usage. And this gives homeowners the ability to monitor that all again from their phone, but they can also adjust their settings remotely as well. And of course, the final piece of technology that I have to talk about is the community battery. This is what enables this community to have microgrid capabilities. In the event of any sort of disruption to the community, this community would be able to essentially island itself and sustain for a period of time. So you can see an example of the infographic here, and we'll talk a little bit more about the microgrid on the next slide. Right now, the community battery is still in the design phase, but we expect to be able to share a lot more details about this once everything is finalized and installed in the next year.
Yeah, Ariel, the community battery is an interesting story. You need rooftops to be served by the battery. So we put it as we now have about 100 plus occupied homes in between the two communities. So there are rooftops available and can take advantage of a community battery. That's so its time has come, but we have not been sitting idle. We've been designing for the microgrid infrastructure and more studies than we ever thought that would be needed. For example, for a microgrid to be on top of the traditional grid and connected to it, what we got to understand is that there must be cybersecurity studies of the efficacy of the microgrid so it can connect to the grid, traditional grid. Very understandable in today's world that we are in, but that's just part of the course, if you will. Let me take a minute and say the items that the hardware that and applications that Ariel went through a few minutes ago, they are really, they comprise a nanogrid, a home as a nanogrid on its own, especially that these homes are designed to be net zero energy ready. Therefore, they have very small load and the battery and the solar on the house will feed it almost as a net zero, right? So it's a nanogrid on its own, yet it sits within a microgrid. And the microgrid, as Ariel said, will have the community battery to support the batteries in the homes, the nanogrids, and together they will be even a stronger microgrid altogether. It basically is, it goes from the utilities. The utilities can feed the community battery and give it power to store, or power can come from the homes to the battery. And then, of course, when it's needed, when islanding happens, then the homes have their own batteries to draw on, and yet when they need additional power, there is power from the microgrid, from the community battery through the microgrid infrastructure. The minute the power is restored to the grid, things go back to normal. This is all facilitated by the Schneider Electric smart all-in-one panel that kind of manages between the backed up and non-backed, non-essential loads. Of course, this microgrid also supports VPPs, and the community battery itself can participate in VPPs to create economic value for the community and the operator of the battery. But at the same time, every home is ready to participate in VPPs as well, and as Ariel mentioned. Next slide, please, Ariel. So let's talk about these home programs, homeowner programs. Next slide. Yeah, the virtual power plant. Basically, it's a way to say, I'm an asset. The home is now an asset on the grid and can support it in terms of load shifting or providing additional generation to the grid. And the storage that is available in each home's battery, as well as I said earlier, the community battery, are these assets that can contribute to the grid. As a builder, we're always looking for additional value for our customers. And of course, the idea that energy as a service comes with even a revenue component to it for the homeowners. Revenue in terms of, yeah, I can participate in demands for energy and export energy at a very healthy price per kilowatt hour is something that is exciting for homeowners and a value that a builder can provide to the homeowners. So participation in the virtual power plant is optional. It's an opt-in program. If one wants to keep the battery all for themselves because they have, say, an EV and they just don't want to be left without any energy, any electricity, that's fine. But it's an optional, and it's optional to participate overall into the program. But it's also, when you see a demand, you can participate in it or not. You also, in sophisticated VPP apps, you can set rules for only participate when the price of kilowatt hour goes beyond over X dollars or cents, if you will. Okay, so very interesting, and I think what excites us about this is that it's not just about batteries, the battery in the garage of each home and the community battery. It's also about the mechanical components in the house, the water heater and the air conditioners, the big loads in the house, and how when you build a home that is net zero energy home, very well insulated, you can stand to be without air conditioning for a few hours, perhaps longer. And that way, yes, I can shut off my air conditioner and participate in a VPP, or the same with water heater. I want to tell you a little bit more about water heaters. So let's go to the next slide, please. So a little bit of a provoking statement. Think about a water heater as another battery in the house, and it is. Some DOE studies in full communities basically didn't have, they considered the batteries in that community as the water heater being the battery. And it works really well, but you got to plan a little bit for it. So the heat pump water heaters from Rheem that we used at our project are 80-gallon water units. So they contain more water than normally the size that we put in typical homes. So we can have water even if we do a VPP event and we shut down the heating of new water. The water that's in the tank already preheated at a very high temperature will remain, and in a sense is a battery storing a lot of energy that could be dispersed to the house later down the line. And that's very simply done because there is a thermostatic mixing valve at top of this water heater. At the exit point from in about a 155, 160 degree water temperature, you need to mix that with cold water so that it can reach its outlets at a safe temperature for residents. But we're storing it in large amounts at high temperature, and that's the battery in a sense. Okay, what's important when you select a battery like this is to also select it with communications ports so that they can respond to demand response and in a sense do this automatically if the homeowner chooses to let it do this automatically without them noticing anything. And there will not be any discomfort because, again, the storage amount that I mentioned. Next slide, please. All right. And one thing that, being that this is a research project of multi prongs, one of these streams that we're studying for DOE and the other partners is using the batteries of cars as a resource for the home and the grid, not a demand point, but actually a resource. And so technology has evolved in that area, and the EV9 from Kia is one of the earliest cars that, vehicles that will be ready to participate in bi-directional charging. And we've had at the project a lab approved car and bi-directional charger to work with, and we were able to, these are the UCLA students that you see there, we were able to do bi-directional from the car back to the home, back to the battery of the home, and potentially out to the grid as well. This is where the big picture of a microgrid and nanogrids will change in the sense that you don't just have the battery in on the wall of the garage, you also have the battery in the vehicle to consider as an asset when needed. And participation in VPPs becomes even a deeper discussion and a deeper revenue source potentially for the homeowner. Next slide.
All right, before we move on from this, I actually just want to explain what's happening in this top right picture right here. This car right here is actually being plugged in, and it is charging and running this TV monitor right here. So you think about the car serving as a battery, and you can kind of start to see what that could mean for the potential future home experience here. So you can't see the wires here, but I assure you the car is powering this TV right here.
And it's also powered the entire home, all circuits in the home, as well as export to the grid. Yes.
All right, so thank you, Jacob. Next, I wanted to talk a little bit about the different aspects of this microgrid project impact. All right, first, this project could not be a success if no one wanted to live in it. So we definitely wanted to make sure homeowners had a good experience. So while not all 200 plus homes are all finished yet, we have already started seeing customers moving in and providing some very positive feedback about their energy smart connected home. So I've included a couple quotes here from actual homeowners. So the top one first, the peace of mind that is associated with the community's microgrid capabilities. When it comes to your home, this is not something we can even begin to put a price on. That's an invaluable benefit for customers that have the opportunity to live in these communities. And second, related to the bottom quote, we know that many jobs these days are mostly remote, and a lot of folks are working from home. So being able to continue working, even if there is some sort of disruption to your grid, is also another added benefit. And I see this almost as another aspect of what we talk about in terms of home resiliency. In terms of the direct microgrid benefits, back at home, homeowners can expect to pay a lot less on their utility bills. And this is an added benefit on top of these homes being built and priced for primarily first-time home buyers. For this slide, I pulled together the estimated energy usage data for the model home that you saw on the first slide. And if you take a look at these numbers, you can see that the annual energy cost for that model home is estimated at $150 annually. Obviously, there are a lot of factors that could make this number go up or down depending once folks start moving in, but still quite impressive, especially when you think about the projected savings that these customers will begin to have year over year. Then at scale, microgrids like these could help utilities avoid things like expensive grid upgrades and also avoid the need to use peaker power plants, which are often turned on at times of peak demand. And these peaker power plants are often known for being the dirtiest to run and the costliest to maintain. So having a dependable supply of energy can really help to further stabilize the grid and reduce that reliance on fossil fuels. And finally, I just want to mention that these communities can also potentially help other surrounding neighborhoods if there is stress on the grid by sending any sort of excess energy back to the grid and diverting energy to power other areas that need it. All right, environmental impacts. So as I mentioned earlier on, these homes are all WaterSense labeled homes. This means that these homes are expected to save at least 30% more water than typical new residential construction. So through modeling, we estimated a savings of almost 63,000 gallons of water saved per home annually. But as many of you probably know on this call, saving water also means the potential to save energy. So we had the EPA WaterSense team take a look at our projected performance, and they provided estimates of our annual water-related electricity consumption on the right. You can see that right here. And that includes categories like electricity associated with extraction, heating, treatment, collection, distribution of water. And now you compare that to a reference home on the left, and you can see the difference is quite large. It's almost, I believe it's about a third of what you're seeing on the left. And of course, the energy savings associated with the water saved just from having a more water efficient home also has a similar impact on reducing the carbon emissions associated with the home. So that is this next slide here. Again, you have the rated home on the right and the reference home on the left. There's an even bigger difference here between rated and reference. It looks like it's almost 5 times less than the reference home here. And I share this slide to really emphasize how all the work that we as builders here put into things like energy and water savings, how all of that can really add up to impact at scale. So for these two communities, we are estimating a total carbon emission savings of over 312 tons. Now, looking to the future with these communities, this microgrid project will be serving as a working laboratory environment to conduct research on for the next 4 years. So all of our project partners will be working together to run simulations on the microgrid operations so that we can gather insight for our industry. We'll also be doing comparison to measure the efficiency of the microgrid performance compared to traditional residential solar communities as well. So this part, this study will be led by the University of California, Irvine's, their Advanced Power and Energy program. So we hope that this first of its kind, energy smart connected community, we hope that this will provide a blueprint for resilient living in the future. There's definitely a lot more to come on this. We expect to continue sharing project insights and findings so that we as the home building industry, we can together can continue to further replicate and scale these types of innovations.
Yeah, Ariel, I know you have this to wrap up, but could you go back one slide, please? Yeah, I just want to clarify here that this study that the WaterSense team shared with us about our community was holistic. It's looking at the water grid, okay? We're talking grids. This is the water grid. It's from the source of the water all the way to the treatment of the wastewater, looking at it and all the embodied energy in that gallon of water from the beginning all the way to end at the waste plant. And so they looked at not just what it takes to heat the water at the homes of the connected communities. They looked at it, or the water, the energy in pumping the water, cleaning the water before it gets to the home. And then, of course, as I said earlier, the treatment of it. And that is huge. You look at that difference in terms of embodied carbon that has been saved. And the conversation now starts to shift to, is water efficiency a great tool for energy efficiency and greenhouse gas avoidance in the future? I think I'll speak for myself. I think it is. And I think it's important that we all, as builders, start focusing more on conserving water so that we can conserve energy and reduce carbon emissions. Sorry to interrupt. We'll take you to the wrap-up slide there, Erin.
That was a great point. So I talked a lot about the energy grid, but there is definitely more than the energy grid to think about here. All right, let's wrap up. So as we wrap up, I'd love to leave you all with this question here, something to think about. How can we continue to do projects like this at scale without the grant funding that we were lucky enough to receive? And with that,
it's a big question. It's what we're trying to understand, and you clearly, to understand that, you might need a public-private partnership to get to the answers. But then, and by sharing the answers also with the community, we as a community can start moving forward. Aaron, we'll turn it over to you with that provoking question.
Yeah, it's the $1,000,000 question, is it not?
Yes.
I really liked what you said about the water, the carbon footprint of water, and we forget about that. And we just hosted a session from EPA WaterSense on their new calculator. And I'm wondering, did you use that calculator to really come up with the numbers specific to this development?
Yeah, we did for this development, but also we have been using the EPA calculator for our ESG reporting that we do on an annual basis. Yes, it's a great tool.
I think that's so important that so many of our impacts from the houses we build come from the long-term operations, and that's an impact we can make on the front side and kind of lock in and guarantee and take the carbon offsets on it. I think the second area I think that you really did some advanced thinking on is the thermal storage capability of the battery, the water, basically a water battery in the house, and upgrading to that 80-gallon ream unit to kind of be a store of energy and allow you to glide through demand events in a more seamless way. So I'm really interested to see the long-term energy cost of doing that versus the resiliency of having it in the house. So I'm sure that'll come out of the data. I think one of my biggest questions as you look at this project is, KB is in a unique position where I think if my intuition is correct, you act as the developer on your projects and as the builder. So what type of infrastructure design and considerations did you have to take into account to really execute something like this on the front side? And maybe what resources did you bring to bear to design it properly?
Yeah, we do. In this particular case, we are the developer and builder. In other cases, other locations, we are builders only. And I would say the good news is that as far as trench infrastructure, there isn't a whole lot different here. Okay, you may need just an additional small tray for a communications loop that is private to the microgrid, and sometimes you can even let go of that. But there are I call them the street furniture. The vaults, the in-ground vaults that we have for transformers and then for controllers in the community. Yes, you need some extra controllers. If you are collaborating with the utility, you may share some vaults with them to put this equipment. But that's if this is done early, and it needs to be done early. If you're working with the utility and not just shutting them out, you need to work with them early on, and anybody that's on this call that's a developer understands how early you need to start working with the utility to design for the utilities trench and all the infrastructure that goes in there. So early work on this is very important. And part of the strategy. Then you start getting into what goes into the home as systems that can, in a very integrated way, support the microgrid. And that's where the Schneider load center comes in, the hub from SunPower or whoever is the battery provider in future communities. That comes into play as part of the architecture and infrastructure. Then communicating switches. You need switches that can communicate with the microgrid and know when to shut shut down the unessential loads and so on. So that's really the infrastructure. You may have a financial infrastructure to put together as well. Okay, I mean, a microgrid doesn't operate in the vacuum, especially without a grant, right? So you do have to have a financial infrastructure in play. The important thing, as we tried, Ariel and I tried to highlight, is think about how do you also generate revenue for the customer, not just fees for the customer.
Yeah. I want to go back to the Schneider Electric because we've learned about this at EBA.
Yeah.
And I think that load shedding panel, the 200 amp load shedding panel that I believe you used, is really critical in this, because you would think if you're going all electric, you could reach a point where you have to go to a 300 amp or 400 amp service. But this Schneider product, it allows you a workaround on that. Can you talk about that a little bit more and how that's been successful for you in this development?
Yeah, there are smart switches and breakers here involved, and it's the prioritization. What we're talking about is the prioritization of the load, and I think when it's all in one panel rather than 2 or 3 panels on the garage wall or the exterior wall, when it's all in one panel managed in the way that Schneider has been innovating, is critical to not have to go to higher different panels and so on, and higher costs, I wanted to say. So it is important. Additional to that is the energy management system that comes together with it. That can, where you start opening it up to the customer as far as what do they want to prioritize as far as loads and things like that. I think we're in the early stages of a lot of this thing, and Schneider continues to innovate and propose new products that really, I think, in the next couple of years will be very impactful in that area, especially as more electric vehicles come to homes, and you need to coordinate a lot of things. One thing I'm excited about, just to add it and perhaps plant a seed, if you will, is how do you now we have so much electricity that comes from different types, from a car to the house, from solar panels to the house, from a battery to the house, and almost if it's done without good thinking and coordination, you're going to end up with 2-3 different inverters in the process. But the new thinking, and again, here's where planting the seed, how do you start working with electricity in its DC form, and perhaps minimize the inverters, because with every inverter, you're losing some of the energy. And so that's an area and an idea that perhaps it's worth for EBA to pursue, and we would love to pursue it further with you in the future.
Yeah, I couldn't agree more. I keep thinking that Nikola Tesla was perhaps correct. It just took 150 years for him to be correct, right?
Yeah.
And that why are we feeding DC load in and then changing it to AC, and then at each LED fixture we're changing it back to DC.
Yeah.
You know, I think there's a future where it can be, most of the major circuits can be served by DC.
Right.
I have a question for you, because I'm so intrigued by the vehicle to grid or vehicle to home product, and to me it seems to be an incredible answer for the future. So I would think that today you structured the development with, you know, the SunPower, SunVault, and maybe like a 13 kilowatt battery at each house. And then you have the vehicle to grid capability coming from the Schneider panel. Do you see a world in the future where perhaps there could be a smaller format battery that's permanent to the house, and then the vehicle or vehicles act as a mobile battery or an at-home battery and can take more of the load? And I think what it does is it keeps first costs down for the homeowner, perhaps. What's your thinking around that for the future?
Yeah, I think a car is an electric vehicle is a battery on wheels, and its capacity is 10 times more than some of the batteries on the market right now, maybe even more than that. So it needs to be used, but the fact that it is not always there is something you want to consider. And I think in your question, you kind of built for that by saying you minimize the battery that's attached permanently to the home and depend on the car. I think it's going to be a lifestyle, a user case type of item. So as a builder building homes for all cases, I'm not sure that we have the liberty to generalize as much as a particular homeowner that's building that infrastructure in their home and their abilities with their vehicle can do. But it's something that we as an industry and community, we need to continue to think about.
I was really intrigued by your working with Kia, and I'm wondering if there's any thought or maybe a future study on, is there the potential to lease a Kia or include a Kia with the battery storage into the homeowner agreement on the front end, thereby having vehicle to grid capability built into the houses?
Can you imagine what Fannie and Freddie will think about that? That's an advanced thinking. Let's see how it evolves. Yeah, the mortgage industry would be very, very curious about this one.
Yeah, yeah. We'll save that for our advanced class. But that takes us back to, I think, the question that Ariel asked, which is how can we continue to do this at scale without grant funding? And you talked about the financial infrastructure being so important. Is there a way, like I look at this and say, is there a way that a homeowners association or the community itself would be able to provide energy as a service to the neighborhood? And with the virtual power plant and the payment for, is there a way to take the cost and package it into a community and have homeowners like you showed that said, you know what, instead of perhaps paying the utility, I would rather support this type of infrastructure? What are your thoughts around that?
Yeah, we love the concept of energy as a service, especially when it comes with resilience and with zero escalation.
That's
into,
right.
Into say 25 years, zero escalation, fully maintained. It's a service. And the concept makes sense. This particular location, Menifee, is a little bit of a distance away from Los Angeles County and Orange County, the dense urban areas of Southern California. It is a destination sometimes that's popular with retirees, move down buyers that also want to make sure that their utility is predictable in terms of its availability, as electricity is here for me all the time, and also its cost is predictable. So when you offer energy as a service, and also let's add another layer, part of the service is to give you an opportunity to make revenue through the VPP. All of it makes a lot of sense. And I think then you start replacing the the potential costs, always escalating costs of utilities. That I think there is a very good story here. Now, where does it go? Does it go in the HOA infrastructure, or is it separate, just as a layer, a utility district layer on here that is paid as a monthly bill, just like the bill for Southern California Edison? These are things that I think marketing teams and customer research will help us evolve how we think about it.
Fantastic. Well, I want to thank you so much. I'm already thinking that like the most incredible general session would be to have KB Homes with SunPower, with Schneider Electric, with Southern California Edison, with UCI, with DOE, maybe with Kia and Ecobee and Broan and Carrier and EPA WaterSense and like the whole team, because it's such an advanced way of thinking about not only the house, and I think we've always thought about the house as a system, but then taking it from that nanogrid scale to this microgrid scale. And I think that's the next frontier for all of us. So I'll be talking to you more about having you out to Salt Lake and checking back in with you come October. I think would be just incredible. So Jacob and Ariel, thank you as always for joining us today. And for everyone, if you missed the beginning or you want to send it to a friend, eba.org in the webinar series, you can watch this in replay.